Hey, welcome back to Fat Mama Physics. In these upcoming two videos, we are going to look at inverse operations, only one-step solutions, not two. This should be a continuation of what the previous video was, which is what is a variable. So in this video, I'm going to go over some simple examples on what are some inverse operations and some basic steps on how to get you started on doing algebra. Here I have a few functions. I have the top row here and I have the bottom row here. So let's take a look at how you would match these following operations to their opposite function. Maybe a good time for you is to quickly pause the video and think about it. Okay, so here I will tell you what we got. If you said the opposite function for adding is subtracting, awesome, good work. Okay. And the next one here is multiplying. The inverse operation of multiplying is your division. Great job. And if you didn't know this already, by process of elimination, you probably figured out that taking the square of a number is exactly the opposite of taking the square root of a number. So those are your opposite functions, meaning that when we see them in an algebraic equation, they will be the tools we'll be using to solve them, starting with example 1. The rule of thumb of whenever you're trying to solve for a variable in algebra is that you always want to isolate for the variable. So what does isolating mean? It means you want the variable on one side of the equation and you want this equal sign here, and you don't care what's on the other side. As long as everything gets moved over to the other side, you leave x by itself alone on one side of the equation, that's called isolating for your unknown, isolating for x, okay? And of course, your variable doesn't have to be x. It could be any letter in the alphabet, or Greek letter alphabets for that matter. But anyways, let's get started with the first example. So here we have x plus 2.4 is equal to 6.5. Now, you might be able to do this in your head already, but I just want to go through the basic steps so that when the problems get harder, you can still use the same steps to follow along, okay? Here we have x plus 2.6. And what we want is we want to isolate the x by putting or getting rid of this 2.4. The only way to get rid of the 2.4 is to subtract it on this side of the equation. And we know that to subtract something on one side of the equation, you must do the same thing to the other side. So I am going to do the following. I'm actually going to write here subtract 2.4 like that, okay? And with the other side of the equation, I could simply do the same thing, but I just kind of want us to get used to thinking that the first thing you should do on the other side is to bracket it, then subtract 2.4. You might be thinking, that doesn't make a difference to my final answer here. You're correct. Here, in the simple steps, sure, it doesn't matter. Later on, you will see the reason why we need to bracket the entire side of the equation before you do whatever operation you're doing, okay? But of course, let's just do this. Because we subtract 2.4 on this side of the equation, this cancels out with adding the 2.4 on this side of the equation. We are now left with 6.5 minus 2.4. And if we do that quickly, that's going to be 1 and 4.1. So you get x is equal to 4.1 on the other side of the equation, and that's called isolating for your unknown, okay? So why won't you try example 3? Good time to pause the video. Okay, so I'm going to go over the example 3. Here we get our unknown, which is now d. Oh, great. D minus 3.2 is equal to negative 18.5. So what I'm going to do is well, hopefully you've done it, which is find the opposite operation here, which is adding 3.2. And of course, you're going to do it on both sides of the equation. Okay, and then you're going to get, and putting in your calculator, so I get negative 18.5 plus 3.2, oops, and that's going to be negative 15.3. So since these are gone, the 3.2's are gone on this side of the equation, I get d is equal to negative 15.3. So we've done adding and subtracting example. Let's go to multiplying and dividing here, okay? Example number 2. Here we have 3n equals to negative 3.6, or if you use words to describe it, that's 3 times the number, 3 times n, is negative 3.6. Now, again, we want to isolate for the n. And of course, every time you see a 3 right beside your variable like that, it's called a coefficient. I'll talk about that again. But that means the coefficient is multiplying the n. So 3 is multiplying the n, meaning to get rid of the 3, we have to do the opposite operation, which is to divide by 3. And of course, if we divide one side of the equation by 3, we must divide the entire other side of the equation also by 3, just like that. So here we get rid of 3 divided by 3 just gives us 1. This goes away. We get n is equal to negative 3.6 divided by 3. That's going to be equal to negative 1.2. Okay, so that's one step solution. Example 4. Good time for you to try and pause the video. Okay, I will do example 4 with us. Now this time we have r and over 4. You might be thinking, ew, that's a fraction. How do I deal with a fraction? Remember, every time you see a bar like that, that always means to divide. Okay, so I don't even see this as a fraction. I just see r divided by 4. Now, of course, division, opposite operation, you might be thinking is multiplication. You are totally right. So let's multiply both sides of the equation by 4. And remember, I'm going to just keep bracketing this just to always remind you that you're doing the operation to the entire side of the equation. So 4 cancel because one on top, one on the bottom. I get r is equal to 7.2 times 4. That's going to be equal to 8.28. Okay, if I've done my mental math right. Okay, so I'm going to go down. And then the last set of examples involve squaring and taking the square root. So I will do example 5, you do example 6. So example 5 here, I have square root of x is equal to 3.4. The opposite operation here is to take the square of both sides. So I'm going to imagine I am bracketing the side of the equation, taking the square. I'm bracketing the entire side of the other equation and taking the square. So square root and the square operations cancel out. I am left with x to the power, x is equal to, and then the other side I have 3.4 to the power of 2. I will just have to put that into my calculator. 3.4 squared gives us 11.56. Okay, and that's our solution for example 5. Here, your chance to try example 6. Good time to pause the video. Okay, and here we go. X squared is equal to 4.7. So here we need the opposite operation, which is to take the square root. I'm going to need to take the square root of the entire side of the equation, just like that. Again, it doesn't matter if my square is on the inside or square is on the outside. As long as these two are side by side, they are opposite operations, they will cancel. I am now left with x is equal to the square root of 4.7, and I just need to put that into my calculator, and I get 2.167. 2.167 ... And if you have a trailing set of decimals, I would just, I'm not going to be very picky on how you round it. A good time to round this one, how to round this one nicely is if you take a look at kind of how you can round it to best represent the number as best as possible. So notice this 7, right beside the 7, there's a 9.4. This is getting very close to the next place value. If I take the 9, I round, it's very close to 2.168. So I would just take the 9 and round the 7 up to an 8. And of course, if the question specifies the place value to round it to, then use that one instead. Okay, so here I would do 2.168. Okay, so here we are. All right, that's example 6. So that's it for these set of examples. In the next video, I'm going to go over some harder problems. Okay, thank you for watching. See you next time on Fan Mama Physics, signing out.